All right, so last class we discussed if statements, not if statements. Last class we discussed Boolean expressions. Today we are talking about if statements. So let's just jump right into it. Brief review of what we talked about last class. Here was that program we made. We got some input. We had the user enter their age, and then we said old enough to vote is going to equal age greater than or equal to 18. And then we were printing old enough plus old enough to vote. So if the user was old enough to vote, we would see true. Otherwise, you would see false. But what if, instead of just printing old enough true or old enough false, I wanted to print a slightly more personalized message like you are allowed to vote, or sorry, but you are not old enough to vote. With what we have currently learned, we can't do that. So what we need are if statements. If statements let us use some Boolean condition to make a decision in our programs. They let us run some block of code only when a certain Boolean condition is met within our program, which lets us have some chunks of our code only run sometimes rather than always being run. So here's what the structure of an if statement looks like. First, we have our actual if. We need the if to, actually do an if statement. Can't have it without it. Next, we have our condition. The condition has to be a Boolean value. You can either use a Boolean typed variable, or we can use a relational operator like we learned about last class. So we can put anything that's going to give us a Boolean value in here as our condition. And notice that we have parentheses around our condition here. In Java, we need to have parentheses around our condition. Otherwise, we will get a syntax error. Now, last section here, we have the body of our if statement. So we have our open and curly brackets. Just like any other time we have open and curly brackets, we can move that one to be on the next line if we so choose. I like how it looks when it's on the same line. You might like how it looks when it's on the next line. Doesn't really matter. The body of the code is going to live inside of those curly brackets, and that code will only run when the condition is true. Otherwise, it's going to skip that code completely. It's not going to run. So if I have my same old enough to vote code, except instead of getting user input, I'm just saying age is 12. When I check age greater than or equal to 18, 12 is not greater than or equal to 18. We get false. So we're just going to skip all of the code that was in our body. So because the condition of the if was false, none of the body runs. Now, if I change age to equal 30, old enough to vote will equal true. Since old enough to vote is true, my condition for my if statement is true. We're going to actually run the output here and print, congrats, you can vote. John, it is okay that your iPad died, but it's understandable. So here we can see either scenario, our if statement will or will not run. We can actually move that whole Boolean value. We don't have to make a Boolean variable in order to make this work. We can just have that relational operator. We can have that comparison happen within our parentheses for our condition. We don't need that separate variable. If we want to make a separate variable, totally allowed to. If we want to just have our comparisons in our if, also totally works. Does it make sense so far? Cool. All right, so we can represent an if statement using a flowchart. So we're going to have some condition. We're going to represent that with a diamond. When our condition is true, we're going to follow this path. If our condition is false, we're going to follow this path. So when it's true, we're going to execute whatever code is in our if statement. when the condition is false, we're just going to kind of skip that code. And in either scenario, we're going to then run any code that comes after our if. So if we look at how we could represent our age greater than or equal to 18 if statement with a flowchart, here's our condition. We're checking, making sure age is bigger than or greater than or equal to 18. If that's true, we'll print you can vote. And then if it was false, we're just going to do nothing. And in either scenario, we're going to continue running any code that we had after the if statement. So after the curly brace for that if. So the flowcharts make sense? Sweet. So if I want to extend this example, let's say I'm going back to user input. I can add a second if statement, checking if my age is less than 18 to say, hey, sorry, you're not actually allowed to vote because, you know, we have our congrats, you can vote, and we also have that they're not allowed to vote. So no matter what they enter here, either one of those two if statements is going to run, and we are gonna see some output. Either yes, they can vote, or no, they can't vote. So what this will look like in, let's hold on. We're gonna say the user enters 50. We're gonna check, is 50 greater than or equal to 18? It is. 50 is greater than or equal to 18, so that's true. So we're gonna run the print line, congrats, you can vote. We'll see that in our output. Is 50 less than 18? No, it is not. So that will equal false, and we will skip that body. And since that's the last line of code, our program is now over. So now we can see what that would look like as a flowchart. So all of our boxes are something happening. So normally in our program, we're just going to have a whole bunch of sequential boxes. Now, when we are adding an if statement, we have this potential offshoot from our straight downward line. There we go. So our first condition, we're checking if our age is greater than or equal to 18. If it was, we're going to say you can vote and return to our normal flow. If it wasn't, we're just going to skip printing and go through to our normal flow. After that, we're going to, in either case, we're going to check is age less than 18. If it was, we're going to say you can't vote. If it wasn't, we're just going to skip and go to the end of the program. In either scenario, we're still going to end up at that program ends box. That makes sense? Cool. All right. So let's write a method is square that will return true when a rectangle object is a square and return false when it's not. So what do we need to do to build this method?
Well, I think you should first have like probably like something to create a rectangle, right?
So this is going to be within the rectangle class.
Okay. Well, then you would just need your if statements. Right?
So we would need an if statement. We would also need our method signature. And then we can have some returns, right? Return true or return false, depending on some ifs. So our method's signature, what is the return type for this method going to be? Based on what I am saying here, what type of value am I going to return? I'm going to return a Boolean. So we're going to make a public Boolean. And our method's name is square. I don't think we need any parameters. Wow, that's not how this is supposed to look at all. I ran out of space. So public Boolean is square. Boom, there we go. Now, How do I check if my width and height are the same?
You could just do like, I don't know. You could just Boolean whatever you want to name it, and then width double equals height.
Exactly. Or we could just use an if statement, right? So we can put the double equals in an if statement. So if my width double equals height, if those two are the same, then I want to return true. And then if width does not equal height, then I want to return false. So there's my full method. Now, I can actually make this a little simpler. I can remove some of this code. I don't actually need that second if statement. I can just make my code look like this. I can just say, if my width is height, return true, and then afterwards just return false. And the reason I can do this is because when I run that return, when that line happens, that's going to instantly end the method. Nothing can happen after I run a return in a method. So that's instantly going to hand back the value true. So if I run this return true, my method is over. It's never going to see this return false. If my condition was not true, if width does not equal height, we're not going to run this return true. So we're going to do the next thing after our if statement. We'll return false. So it's impossible for us to run both of those because we can only run one return within a single if statement, or within a single method, sorry. Does that make sense how we can make that change? Sweet. Here's a little flowchart showing what that would look like. We're checking if width is the same as height. When that's true, we're going to return true. And since return is going to end the method, we don't have anything following this because there's nothing left in the method. If that condition was false, then we're going to follow the false path and return false. So we only have those two options here. Now, it is actually possible to accomplish this without an if statement because we can just return the value we get from width equals height. But if we wanted to actually demonstrate the if statement, here's how we would do it. So it's possible to do this without an if statement, but for the sake of example, here we go. All make sense? All right, sweet. That is our lesson for today. Yep, that is it. Oh, stop recording.